Graph the following semicircle and state the maximal domain and range. So if we have a look at the rule, we can see that as there's no sign out the front of this square root, this is going to be the top part of our circle that sits alongside the x-axis. We can now have a look at the transformations that have occurred to this semicircle. So the first transformation we can acknowledge is that this has a radius of 6 units. And that comes from this term here under the square root sign. So square root of 36 is 6, and that gives the radius of our semicircle. We can also see that it's been translated 3 units in the negative x direction, and that comes from the x plus 3 in this position. Finally, the graph is translated 7 units in the positive y direction, and that is a result of the plus 7 in that position of the equation. So because of the translation of 3 units in the negative x direction and 7 units in the positive y direction, we know that the middle of our semicircle occurs here, and that is at negative 3, 7. And because we have the positive half, or the top half of the semicircle, we don't have any x-intercepts. So our semicircle is going to go somewhere here. Using our knowledge of the radius, we know that this position here is minus 3, and then 6 more in the negative x direction is negative 9, 7. And we can also have negative 3 and add 6, and that will give us 3, 7 as the two endpoints for this semicircle. Similarly, the maximum point on the semicircle is at x is negative 3, and we have 7, and we add 6 to it, and that will be negative 3, 13. The last point that we need to find is the y-intercept, and we find the y-intercept by letting x equal 0. So when x is equal to 0, we have y equals the square root of, and it's going to be 36 subtract 0 plus 3 all squared plus 7. So if we evaluate that, we have y equals the square root of 36 subtract, and 0 plus 3 all squared is 9, and then we still have plus 7, and then we have y equals, and we have the square root of 36 subtract 9, which is 27 plus 7, and if we simplify that down, we have y equals, and now the square root of 27 can be written as the square root of 9 times the square root of 3, which will give us 3 root 3. So this becomes 3 root 3 plus 7, and that is that coordinate here. So 0, 3 root 3 plus 7 is the y-intercept. For this question, we also needed to state the maximal domain and range. So the domain of this graph is all the x values that the rule can take. So if we have a look, it goes from negative 9 is the smallest to 3 is the largest. So we have x is an element of, and negative 9 is included on the graph, so we have a square bracket, through to 3, which is also included, so that's another square bracket. And next we find the range, which is the y values that this rule generates. So that will be y is an element of, and now the smallest y value is 7, and that is included, so we have a square bracket. And we go up to the largest y value, which is 13, and that also is included, so we have another square bracket. On this slide, a computer has been used to generate a more accurate graph of the semicircle. And once again, all of the key features remain the same as what we've previously found. And over here we can see that our maximal domain is between negative 9 and 3 both included, and the maximal range is between 7 and 13, and both of those values are also included.